Bismillahirrahmanirrahim. We are studying our chapter 9, that is the last chapter of our this course, that is automotive technology, and that chapter name is hybrid vehicles. These are my credentials just for your info. The basic slide of our course. We have covered all these topics in our previous lecture, and we are now at the last topic of our this course, that is hybrid vehicle. So I straight away goes, today is the part 2 of this chapter. So I straight away goes to the part 2 of this lecture. We are now in last lecture, we have just touched upon these headings, that classification of hybrid electric vehicles. There are 4 types of hybrid electric vehicles, that is series hybrid, parallel hybrid, series parallel hybrid, belt alternator starter system. So let's study one by one. Now in series hybrid, the engine solely charges the battery while the electric motor drives the vehicle. So in series hybrid, the engine solely charges the battery while the electric motor drives the vehicle. So engine do not drive the vehicle. It's only the batteries which drives the motor, and that motor drives the vehicle. The advantages of using a series hybrid: greater flexibility in engine operation, leading to better efficiency, quiet and smooth electric driving experience. So these are the two, in simple words, the advantages of the series hybrid vehicle: that it has greater flexibility in the engine operation, leading to better efficiency, quiet and smooth electrical driving experience. And there are two disadvantages: less efficient at higher speeds due to the engine involvement in charging the battery. So at higher speed, this is a disadvantage, that engine is involved in charging the batteries. Heavier and more complex than parallel hybrid. As compared to the parallel hybrid system, it is heavier and more complex. Let's see further details. Now, the electric energy from the batteries comes from an onboard energy source, such as internal combustion engine. In this design, the engine turns a generator, and a generator can either charge the batteries or power an electric motor that drives the transmission. So the electric energy for the batteries comes from an onboard energy source. An onboard energy source is, we are having an internal combustion engine, none other than that. In this design, the engine turns the generator, and the generator can either charge batteries or power an electric motor that drives the transmission. The internal combustion engine never powers the vehicle directly. The vehicle could be moving with or without the internal combustion engine running. So the internal combustion engine never powers the vehicle directly. We will see in this figure, next figure, which on next slide. The vehicle could be moving with or without the internal combustion engine running. In series hybrid vehicles also uses regeneration braking to help keep the batteries charged. So we are having regeneration braking system that is used help to keep the battery charged. No transmission, clutch or torque converter is needed. All power needed for heating and cooling must also comes from the batteries. So let's see the figure. This is the simple figure, this series hybrid figure. This one, a drawing of the power flow in a typical series hybrid vehicle. We have this engine here, is a gasoline engine that is driving the generator. From that generator, the voltage, the current is going to the inverter, and from that inverter, it is going to the electric motor. That electric motor is driving the reduction gear, and that reduction gear is driving your drive wheels. So from the batteries, the current or voltage are coming to the inverter, and from that inverter that goes to the motor, and that motor drives the vehicle. So it is like this. Basically, this electrical energy which is going from the generator coming to the inverter, and that inverter drives the motor, and motor then drives the reduction gear, and that reduction gear drives the driving wheels. So let's see more complex diagram of series hybrid. This is a figure 89-4 in your book. This diagram shows the components indicated in a typical series hybrid design. The solid line arrows indicates the transmission of a torque to the drive wheel. The dotted line shows the dotted line indicates the flow of the electric current. Now we have engine here. Engine is giving its power to the generator. From then generator, after rectifying the electric power, it's going to the battery and going to the motor. Then this motor controller drives the motor, and that motor drives the mechanical transmission or the reduction gear, and that reduction gear drives the drive wheel. So this is your series hybrid system. Now let's see the parallel hybrid system, the second classification of the hybrid system. It uses both the engine and the electric motor to power the vehicle simultaneously. So in series, only the batteries are driving the vehicle, but in this parallel hybrid system, we are using both the engine and electric motor to power the vehicle simultaneously. Now, a few advantages and disadvantages. It's improved fuel efficiency compared to traditional cars. Regenerative braking captures energy and recharges the battery. In disadvantages, we have limited electric only the range, relies on the combustion engine for higher speed and acceleration. So these are the disadvantages, that limited electric only range and relies on the combustion engine for higher speed and acceleration. Let's see the diagram. Further explanation. After the further explanation, we see the diagram. In a parallel hybrid design, multiple propulsion sources can be combined, or one of the energy source alone can drive the vehicle. So multiple propulsion sources are your internal combustion engine and the batteries can be combined, or one of the energy source alone can drive the vehicle. In this design, the battery and the engine are both connected to the transmission. So here the battery and the engine are both connected to the transmission. Due to this design or this feature, we have smaller size of engine is a big advantage in this parallel hybrid system. Disadvantages are requirement of the complex software for seamlessly blend electric and internal combustion engine power, and proper heating and air conditioning system operates when the internal combustion engine stops at idle. So disadvantages are the requirement of a complex software for seamlessly blend electric and internal combustion engine power, and proper heating and air conditioning system operation when the internal combustion engine stops at idle. Let's see the figure. A simple figure, this one, the power flow in a typical parallel hybrid vehicle. We have this engine, gasoline engine. We have this transmission here, and then this transmission is driving the reduction gear, and then reduction gear, it is driving the driving wheels. We have this battery source here, but from battery it is coming to the inverter. From that inverter it is going to the motor oblique generator, and from motor generator it going to the reduction gear, and reduction gear and goes to the wheels. Let's see a detailed diagram. It's a diagram showing the components involved in a typical parallel hybrid vehicle. The solid line arrows indicates the transmission of a torque to the drive wheels, and the dotted line arrows indicates the flow of a electric current. So this is your engine from, we have a mechanical coupling. From mechanical coupling, we have mechanical transmission, and mechanical transmission, the final drive and the differential, and differential, it goes to the drive wheel. And this also going here. the power is going to the wheels from the engine in this direction. Now we have a battery here. From battery, we have a motor controller. From motor controller, it is coupled with mechanical coupling and then mechanical transmission, final drive. And engine electric is also charging the battery here. And from the regenerative system, from braking regenerative system, the batteries are also recharged. So this is how the parallel hybrid system works. Now the next is combination of the series and parallel hybrid system. That is the third classification. Now in series parallel hybrid system, they can operate using electric motor power alone or with the assist of the internal combustion engine. So in series parallel hybrid combination, they can operate using electric motor power alone or with the assist of the internal combustion engine. Series parallel hybrid combines the function of both a series and a parallel design. In series parallel hybrid system, it combines the function of both a series and a parallel design. The internal combustion engine may be operating even though the vehicle is stopped. So the internal combustion engine may be operating even the vehicle is stopped. If the electric controller has detected that the batteries need to be recharged. So if your vehicle is stopped and your batteries needs to be charged, your engine will be running. The Toyota and Ford hybrids are classified as series parallel hybrid vehicle. So the most of the hybrid vehicles which you see on the roads, the Toyota and the uh, Honda or the Ford, they are using this series parallel hybrid combination system. Now, the typical diagram, the series parallel hybrid designs allows the vehicles to operate in electric motor mode only or in combination with the internal combustion engine. So we have this gasoline engine here. From this gasoline engine, the power is going to the power split device. From that power split device, it is going to the generator and to the reduction gear. From reduction gear, it is going to the drive wheels. From this generator, it is going to the inverter. From the inverter, it is driving the motor and motor to the reduction gear and drive wheels. And battery source, from battery source, the power is coming into the inverter from the motor and motor to the reduction gear and going to the drive wheels. So this is how the series parallel hybrid vehicle system works. Now, the fourth and the last of the classification is the belt alternator starter system. The belt alternator starter concept is to replace the belt-driven alternator with an electric motor that serves as generator and a motor. So in this belt alternator starter concept is to replace the belt-driven alternator with an electric motor that serves as a generator and a motor. When the engine is running, the motor acting as a generator, it will charge a separate 36-volt batteries. 42 volts charging voltage is required at that moment, so that generator is producing that much of a voltage. So when the engine is running, the motor acting as a generator, it will charge a separate 36-volt batteries with the help of 42 charging voltage. When the engine needs to be started again, after the engine has been stopped at an idle to save fuel, idle stop, the belt alternator starter motor is used to crank the engine by taking electrical power from the 36-volt battery pack and applies its torque via the accessory belts and cranks the engine instead of using the starter motor. So when your engine needs to be started again, the engine has to be after the idle stop. The belt alternator starter system motor is used to crank the engine by taking the electrical power from your battery source, that is 36-volt battery pack, and applies its torques via the accessory belt and cranks the engine instead of using the starter motor, which we are using in a conventional vehicle. The belt alternator starter system uses a conventional starter motor for starting the internal combustion engine the first time, and you only uses the high voltage motor generator to start the internal combustion engine when leaving idle stop mode. So for the initial start, we are having the conventional starter motor, But after that, we are using high voltage motor generator to start the internal combustion engine when leaving idle stop mode. Let's see from the figure. So the component of a belt alternator starter system, we have this engine. This one is your engine, and we have a power modified automatic transmission with the auxiliary pump here. And this is your motor generator with three-phase cable. And this three-phase cable is going to your power electronics with inverter and DC converter. And then we have this ECM, engine control module, with hybrid supervisory software. And we have this power pack, advanced nickel metal hydride hybrid battery pack with auto disconnect, located under the rear seat. And here we have dual tensioner assemblies. So this is how your belt alternator starter system works in a vehicle. Now the time versus vehicle speed, the chart shows what is occurring during various driving condition in belt alternator starting type hybrid vehicles. On x-axis, we have time. On y-axis, we have vehicle. The first, engine off when the vehicle is stopped, means not the initial start. It is idle stop. So this portion is your idle stop. After this is the brief electric operation here. After this brief electric operation, then we have auto start with torque smoothing here, this interval. And then this is the electric power assist here. After this electric power assist, we have a fuel on here. And then we have auto start on this. Sorry, I repeat again. This is the engine off when the vehicle is stopped here. This is the brief electric operation. And then this interval is the fuel on, and this is the electric power assist. After the electric power assist, the auto start with smoothing, and this is the interval, and then electric power assist here, and then regenerative braking here. Intelligent charging of advanced hybrid battery starts here, and this interval fuel cutoff during D-cell with torque smoothing and brief electric operation here. So regen. So all these are the intervals which we face in the belt alternator starter system. Now the common features of most hybrid, the idle stop. The idle stop mode turns off the engine when the vehicle is stopped. When the brake is released, the engine immediately starts. This ensures that the vehicle is not using fuel, nor creating carbon dioxide emission when the engine is not required to propel the vehicle. So the idle stop is in idle stop mode, it turns off the engine when the vehicle is stopped. When the brake is released, the engine immediately starts. This ensures that the vehicle is not using fuel nor creating carbon dioxide emission when the engine is not required to propel the vehicle. Regenerative braking. When deaccelerating, the braking system captures the energy from the vehicle's inertia and converts it to the electrical energy, which is stored in the batteries or other devices for later use. Regenerative braking helps keeps the batteries charged. So regenerative braking is basically when it's capturing the energy from the vehicle inertia and converting it to the electrical energy and then storing into the battery or other devices for later on use. So when deaccelerating, the braking system captures the energy from the vehicle's inertia and converts it to the electrical energy, which is stored in the batteries or other devices for later use. Regenerative braking helps keeps the battery charged. Now, power assist. The electric motor provides extra power using electric current drawn from the batteries to assist the internal combustion engine during acceleration. This power assist mode enables the vehicle to use a smaller, more fuel efficient engine without giving up vehicle performance. So this power assist, the common feature of a hybrid vehicle, The electric motor provides an extra power using electrical current drawn from the battery to assist the internal combustion engine during acceleration. This power assist mode enables the vehicle to use a smaller, more fuel efficient engine without giving up vehicle performance. The fourth one, the last one, engine off, drive electric vehicle mode. The electric motor propels the vehicle at low speed. This mode is often called motoring mode. The electric motor propels the vehicles at low speed. You have heard when you are driving the hybrid vehicle at low speed, you have heard the noise of a electric motor in a very low speed. This mode is often called as a motoring mode because the internal combustion engine is not being used during acceleration. No fuel is being used and no emissions are being released. When the hybrid is in this mode, it is essentially an EV, electric vehicle. So basically it's very for very limited time, initial time. Now, after the last lecture, there was one question asked, what is the difference between hybrid electric vehicles and plug-in hybrid electric vehicles? So I will explain it with the help of 5 characteristics. First one is with the help of power source. In hybrid electric vehicles, runs on both internal combustion engine and an electric motor. The battery is charged only by the regenerative braking and the engine itself. You cannot plug it in the hybrid electric vehicle. There is no plugging in. Okay. In plug-in hybrid electric vehicle, similar setup we have internal combustion engine plus electric motor, but there is an other additional feature that is the battery is much larger and can be recharged by plugging into an external power source, home outlet charging stations. As we have seen the electric charging station, where we have a plug-in hybrid electric vehicles, goes there and charge. Electric only drive range. Hybrid electric vehicles, very limited, usually 1 to 3 kilometer of electric only drive, mainly at low speed city traffic or when starting. In plug-in hybrid electric vehicle can travel up to 30 to 40 kilometers, sometimes more. Basically, it's more on electric power alone before engine kit starts operating. So this is with respect to the electric only drive range. Now with respect to the fuel economy, hybrid electric vehicle improves fuel economy compared to your conventional cars, but still relies mostly on a gasoline or the diesel. In plug-in hybrid electric vehicles offer a better fuel economy and lower emission if you frequently charge it and drive short distance on electric mode. And fourth characteristic, charging. Hybrid electric vehicle, no charging cable needed, battery recharges automatically. But in plug-in hybrid electric vehicles, you require a charging by plug for best performances. Without charging, it behaves more like a regular hybrid electric vehicle. Now, the last, the point with this, or the characteristics with respect to the cost. Hybrid electric vehicles generally cheaper than the plug-in hybrid electric vehicles. Plug-in hybrid electric vehicle more expensive due to larger batteries and charging system, but may qualify for tax incentives in some countries as which we have in our country here. So this was the lecture for today. We will cover rest in the last part. So thank you very much.